Hey guys, so in this video we will continue with intermediate algorithm scripting, and we're going to solve seek and destroy. Okay, so we have an initial array, the first argument in the destroyer function, so the array is only the first argument followed by one or more arguments. Okay, we need to remove all elements from the initial array that are of the same value as these arguments, and we need to use the arguments object. Okay, so as you can see in the definition of the function, we only know for sure that we will have an array as the first argument, but we don't know how many more arguments we will have. So for that, we are going to use the arguments object. This arguments object in JavaScript lets you gives you access to the arguments given to the function. As you can see here, the destroyer has the array as an input, but also two more arguments. So let's first try to console log what we get from the arguments. Okay, as you can see, we get this object, and now we want to access this, and I think so we should use the spread operator in JavaScript, which we learned before. Let's call all the arguments that we get after the array rest, so we will put them into a rest array. I'm just going to declare let rest here, and then to do the spread operator I'm going to do something like this. So I'm putting 1 comma here because we want to ignore the array, because we can access it with variable array, and we want all the arguments after the array. For that I'm using the 3 dots, the spread operator rest. This is going to be equal to arguments. Now let's see if we got that right. So I'm going to console log the rest. Yep, as you can see we have all the arguments, so it doesn't matter even if we give 4. Okay, we get all the rest of the arguments. Perfect. I think this was the most tricky part. Let's remove these console logs. Okay, here we are. Now what we want to do is that remove all elements from the initial array that are of the same value as these arguments. So if one element in this array is also in this rest array, then we want to remove it. Okay, that's very easy if you use filter. So let's just use filter. I'm going to use filter here, and I'm going to give it a callback function. Let's write it, element. And now what I want to do first is check if this element is in the rest array. And we're going to use again includes, like in the previous exercise. Rest.includes element. But we want to, so this will return true if it is, but we want these elements to be excluded, to be filtered out. So for them to be filtered out, we need this to return false. Okay, so but let's see first what it does at the moment. Console.log. Okay, so we get 2323, and so we want 11. Okay, so we want to remove 2323 in this case. For it to return false, just like we did in the previous exercise, I'm going to just put to negate it. Okay, and I think that does it. Yep, I think this is all the code. Let's run the test. Okay, perfect. Okay guys, that was it for this exercise. I'm trying to keep it short and sweet. So if you like it, again, subscribe and share to support the channel. Thanks again. I'll see you in the next one. Bye bye. Hey guys, welcome back. So we will continue with intermediate algorithm scripting. Today I'm going to solve wherefore art thou? Okay, we need to make a function that looks through an array of objects, which is the first argument, and returns an array of all objects that have matching name and value pairs, which is the second argument. Each name and value pair of the source object has to be present in the object from the collection if it is to be included in the returned array. So here's an example. We have this array of objects. One object is this one with the first name Romeo, last name Montague, or I don't know how you pronounce that. Then is Mercutio, the first name, and the last name is Null. And then we get Tybalt Capulet. Okay. And the second argument is this object with a key with a property last and the value Capulet. So we must return the third object, this one, because it has also the property name and the value the same as the second argument. Okay, so here is the function. We have the collection and the source, which is an object, and this one is an array of objects. Okay, so first thing we need to do, I think we should get all the properties from this source object, because it might be more than one. In this case we have only one, but yeah, okay, for this example we have an object with two properties. So first let's extract all the properties so we can use them to check, to perform the checks. Okay, I'm going to declare a variable props, and it is going to, we're going to use a method keys, which takes the object source, and what this does is just extract the properties. It gives us an array of properties from this object. So in this case it should give us last. Okay, let's console log this. Props. Yep, okay. But if we had more than one property here, it would give us the array of all the properties. Okay, so I think the shortest way to do this is to use filter. So I want to filter through all the collection and get only the objects that fulfill the condition. So we want to return this array, and I'm going to make this array the filtered collection. So I'm going to do collection.filter. Okay, so now we are iterating through all the objects in the collection. So I'm going to do this object. Let's go into a new line so it's easier. What we want to check in this object, we want to check that all the properties of this object, so all the properties here, all the props are in this object, and that the values of these props from the source are the same in the object. Okay, so I think the best way to check for all the properties is to use the method every. Okay, if you remember, we learned about that a little while. So what this every does is it iterates through all the properties to check for each one in one object of the collection. Okay, and I have to write another function here, prop. This one. So this is the same as having two nested loops. Okay. Now, what I want to check here is that object has own property. This is the method to check if it has a property with the name prop. Okay, so this is the first thing we want, but we also want that the value at that property for object, so object, I'm using the bracket notation prop, should be equal to source prop. Okay, so this will check, so this condition will check if the object has the property and it has the same value as the source. And we need this to be true for every property. That's why we are using every. If it's not, so if it's true for every property, this one will return true. So filter will do its thing. If this one returns false, so even if one property is missing, one property of the source is missing in the collection, or it doesn't have the same value, then this will return false. So it will be filtered out. Okay, which is exactly what we want in this case. I think this one should do it. Let's maybe clean this up a little bit. Okay, so this one should work. Let's run the test. Yep, it does. Yeah, it does it. Okay. Okay guys, so I'm going to keep these videos short, only one exercise per video, so it's easier also for you to check out the solution in my playlist. Don't forget to like, share, subscribe, hit that bell notification icon as always. Thank you for watching. I'll see you in the next one. Bye bye. Hey guys, welcome back. So we will continue with intermediate algorithm scripting, today with Spinal Case. So the exercise question seems pretty straightforward. We just need to convert a string to spinal case. Spinal case is all lowercase words joined by dashes. Okay, so here we have some examples. So we need to make everything lowercase, remove the spaces and make them dashes. Okay, we can do, let's try something. So first, let's just do a split on the string. We can do it right here. I'm just going to split by the dash. Oh, we also have underscore. I think I saw some, or no. Oh yeah, we have also underscore, so we need to split by, let's make regular expression. Okay, let's use regexes. That regular expression is going to be, and I'm going to check for here a space or an underscore maybe, and I'm going to use the plus, so there might be more than one. Okay, and I want it this globally. So let's split by this regular expression, and let's see what this does. So I'm going to console log this. Okay, yep, that's exactly what we want in this case. Let's map everything, so we make lowercase map word dot lowercase. Okay, word. So this should be an array. So map should work on this. Oh, it's too low maybe. Yep, okay. So this is what we want, and then just join. And we want to join it by a dash. Yeah, this seems to be working. Oh, now that I think of it, we don't need this map. We can just join everything into a string first, and then oh yeah, if you join and make a string first, we can just apply to lowercase to all. Yeah, let's try without the map. Okay, and then to lowercase. uppercase. Yeah, perfect. This is much shorter. Let's run the test. Okay, so we have some other use cases for which okay. So we have to think for this case as well. Let's see what this does. Okay, because there's no spaces, we want to split by so the best way to do this is to add an underscore, for example, right here, before we do all this splitting and joining. Okay, so let's do something to make a new string, to do string dot replace. So we are going to use the replace we learned using regular expressions in the previous lessons. What we want to get is we want to grab this part, all parts like this, where we have a lowercase letter and then it starts with an uppercase letter right away. Okay, so to grab that, we need this replace takes two arguments, a regular expression and then something we want to replace it with. So let's give the regular expression first. I want to check for A to Z, which then and then an A to Z, uppercase. So I want to grab only this part. But if I want to replace it, I'm going to use groups, because I want to reuse these groups in the replace. Okay. Okay, so what I want to do in this case is just add an underscore in here. Okay, so now I want to give the thing I want to replace it with. I'm just going to give a string, and I can use the group. So this one means, so $1 means that I am using group 1, so I'm using the lowercase letter, and then I am just adding an underscore between and an uppercase letter. Okay, let's print the new string, new str. This is happening only, okay, let's make it global. Yep, perfect. So this is what we want in this case. We just want to add underscore, so when we go through the splitting, it is covered by this regular expression. Okay, so new string, let's remove this console log, and I'm going to use new string here, new str. Okay, now it should work. Let's run this. Yeah, perfect. Okay guys, that's it for this exercise. Make sure to like, share, subscribe, and I'll see you in the next video. Bye bye. Hey guys, welcome back. So today we're going to continue with intermediate algorithm scripting, and we're going to solve Pig Latin. Okay, let's get started right away. Pig Latin is a way of altering English words, and the rules are as follows. If a word begins with a consonant, take the first consonant or consonant cluster. So we have to take all the consonants in the beginning if there are only consonants, and we need to move it to the end of the word and add AYA to it. But if a word begins with a vowel, just add way at the end. And we just need to translate the provided string to Pig Latin. Okay, so what we need to do in this case is we need to start iterating through the string and then check if it is a vowel or not. Okay, so let's get started writing this. First, we need to I will create a string with all the vowels so that I have them, so I can use them right here to perform a check. So let's declare the vowels. I'm going to make it an array with A. I should remember all the vowels. A, E, I, O, U. Let me check if I have all the vowels correct. Okay, yeah, there are only 5 vowels in the English alphabet. So these are the vowels. Now I want to create a string where I want to keep the cluster of consonants. Okay, it might be 1 or more, or 0 if there are no consonants. So this is the cluster of consonants at the end of consecutive consonants at the start of the word. So I'm going to call this cluster, and I'm going to initialize it as an empty string. Okay. Now we want to go through the string to check if it's a consonant or a vowel. So we need to iterate through it. I'm going to use a for loop. I'm going to create, like always, I equal to 0, I smaller than str.length, and then I++. Okay. So what we want now, I'm going to make this larger. So let's check first if it's a vowel. So I want to check the character at index I if it is a vowel. So if, and how can I do that? So I want to check if stri, if this one is equal to any of the vowels right here. The best way and the shortest way, I think we can do it using sum. We learned about sum in a previous lesson. So you can write something like this. I'm going to take vowels. Let's make a space here. Vowels dot sum, and inside you can write a function, and then that function. So we are iterating through the vowels, and we can apply a function to it, and we want at least we want any of these to fulfill the statement in that function. Okay, so we want if any of this is equal to stri, then for us this one should return true. Okay, so let's write function here. I'm just going to call the element v for vowel, and then what I want to check is that if v is equal to stri. Okay, now this one should return true only if the first if stri is a vowel. Okay, and if it is a vowel, we just want to break. In this case, we want to break the loop. We don't want to continue no more. But if it is not a vowel, we just want to so it means it is a consonant, and we want to add that consonant to the cluster. Okay, so cluster, I'm going to add stri. So what this means is that when this so let's go through a scenario. So in this case, if we have consonant, we iterate through consonant. The first letter str0 is C, then C is not so this one is not fulfilled, it returns false. We go to this one, and cluster now becomes C. Let's just first let's try this now. What do we have? Console.log, and I'm going to print the cluster. Okay, so we have only C. That's what we want in this case, because when we go to O, it is a vowel and we just break. Okay, so we have the cluster of consonants. Now, we want to cover the case. So what happens if the first letter is a vowel? Of course, it will break immediately. And if the first letter is a vowel, the cluster will be still an empty string. Okay, so now we can write an if condition. After we have finished running the loop, if cluster is equal to an empty string, let's remove this. If cluster is equal to an empty string, then we want to just return what is the rule for if it begins with a vowel. We just add way at the end. So we just want to return str plus way. Okay, now if the cluster is not empty, then we just want to take that cluster. Let's remove this. We just want to take that cluster, add it at the end. So it's cluster, and we also want to add way. Okay, let's see what this prints. Okay. Oh, so we also want to remove the cluster. Yep. And to do that, it's pretty easy using the slice function. So slice, I want to cut from, if I have the cluster with one element, then I want to start from one. So we can start from the length of the cluster. And I'm just going to leave the parameter. I'm not going to give another parameter, because that means we can take the string from the cluster length at the end. So from 1 till the end. And this one gives us what we are asking for in this case. Yeah, I think this one should work. Let's run the tests. We have something here. Let's see what happens for California. Yeah. Okay. I want to add A if it is a consonant. Yep. I think that one was the issue. Oh, perfect. So I think that's it for this video. In the next one, we will continue with search and replace. Okay, guys, thanks again for watching. Don't forget to subscribe. I'll see you in the next one. Bye-bye. Hey guys, welcome back. We will continue with intermediate algorithm scripting, and today we're going to solve search and replace. Okay, let's get started right away. I'm just going to make this right side bigger so I can write code more comfortably. Now, we need to perform a search and replace on the sentence using the arguments provided and return the new sentence. Okay, first argument is the sentence to perform the search and replace on. Okay, it is the string here. The second is the word we will be replacing, so before. And the second argument, the argument is what you will be replacing the second argument with after. Okay, so we want to find this word in the string and replace it with after. That's pretty easy with the replace method in the string, but there's something which makes it a bit more tricky, because we need to preserve the case of the first character in the original word when you are replacing it. So if we mean to replace the word book, uppercase B, with the word dog, with lowercase d, it should be replaced as dog. Okay, so let's get started with it. The first thing we want to do is we want to change the case of the first letter in after, so it is the same as before. Okay, so we need to check if before has the first case, the first letter uppercase or lowercase. To check if the first letter in before is uppercase, we do something like this. Put an if condition, and let's access the first letter, which will be the string with index 0. And if it is uppercase, it should do something which we can check it like this: before 0 dot to uppercase. So what this does is it converts the first letter into uppercase, and we want to check it with the first letter before converting it. If this is true, it means that the first letter of before is uppercase. Okay, so if the first letter of before is uppercase, we want to make the first letter of after uppercase as well. So after is going to be, let's take the first letter after at index 0 dot to uppercase, and then we're going to edit the rest of the after string. So after dot slice starting from 1. Okay, so starting from 1 till the end. This is the case when the first letter in before is uppercase. Okay, and else should cover the cases where the first letter in before is lowercase. So we want to make sure also that after is lowercase. 0. Now we're going to do the opposite: 2 lowercase plus after dot slice 1, starting from 1 till the end. Okay, let's do a test. Now I want to console log after. As you can see, it stayed the same, leap, because jumped was uppercase. Let's do this. Okay, so if you do this uppercase, then leap becomes uppercase. This is exactly what we want in this case. So I think this was the tricky part. Now we can just use the replace method in the string. I'm just going to do a replace, and I'm going to give the string I want to replace before with after. Okay, let's remove this console log, and I think this one should do it. Let's run it. Yeah, perfect. Okay, I think guys, that's it for this video. I'm going to, as I mentioned, I'm going to keep one exercise per video. In the next one, we will continue with DNA pairing. Thanks again for watching. Don't forget to subscribe to support the channel. I'll see you in the next one. Bye bye. Hi guys, welcome back. We will continue with intermediate algorithm scripting, and today we're going to solve the DNA pairing exercise. So let's see. We have a DNA strand which is missing a pairing element. We need to take each character, get its pair, and return the results as a two-dimensional array, so as a nested array. The base pairs are only pairs of A and T and C and G. We need to match the missing element to the provided character. Here's an example. We got GCG and we return GC. So the pair for G is C, the pair for C is G, and the pair for G is C. Okay, this is what we need to return. So when we get a string like this one, we need to iterate through all the characters in the string and get its pair. To make it easy to get the pair, let's first create an object with all the pairings. Okay, that would be the easiest way. I'm going to create a constant pairing, and it's going to be an object. I'm going to give as a property the first element, so for A, and as a value I'm going to give the paired, the next character which is paired. So A is paired with T, then of course T is paired with A. Okay, then G is paired with C, and C is paired with G. Now why do we need this? This will make it easier to find the pair. For example, if I want to get the pair of A, I'm going to do something like this. I'm going to use the pairings object, and I'm going to give as an input the character. Okay, and it gives me T. If I want to get the pair of T, I get A. to make it easy to access the pairings. Now I think it's pretty easy what we need to do. First, let's just split the string into an array. Okay, I'm going to do split. Let's see what this does. And it gives us an array with all the characters in the string. Now what we need to do is just use map in order to map each element into another array which will have the pair. Okay, so G will be mapped into this one, GC, the pair. Let's use map, and I'm going to have the function element go to. Now what we want to return is an array with only two elements, the element and its pairing. Okay, so element will be the first, and then I'm going to get the pairing. To get the pairing, I'm going to use the object pairings, and using bracket notation, I'm going to give element. Okay, so this actually gives us what we want. I think this should cover all the cases. Let's run it. Okay, perfect. Okay, guys, I think that's it for DNA pairing. I'll continue in the next video with missing letters. Thanks for watching. Don't forget to subscribe. I'll see you in the next one. Bye bye. Hey guys, welcome back. Today we will continue with intermediate algorithm scripting with the missing letters exercise. Okay, it's pretty straightforward. We need to find the missing letter in the past letter range and return it. If all of them are present, then we need just to return undefined. Here we have some examples. A, B, C, E should return D because D was missing there. Okay, so my idea is that we should convert these characters A, B, C, E into ASCII code, and usually ASCII code, so there's an ASCII code corresponding to each character, and for consecutive letters like A, B, C, D, also the ASCII code should be a consecutive number. Okay, but I think it would be better explained through the code. Let's try something here. So I'm going to do console .log str0. Let's see the first letter, which is A. I think we can do something like .code at char and then 0. Wait, I have to check the method. Actually, the method in JavaScript is char code at, and this one returns the ASCII the code for the letter A. Okay, if we try 1, it's 98, and 2, it's 99, because we have A, B, C in this case, A, B, C. And for E, so the third, you'll see 101, so we jumped one because we skipped D. Okay, so we're going to use this. So first thing, I want to range through. I want to create a for loop going through all the characters from the start A to E, and then we can try to find the missing one. So to do that, I'm going to create a start. I'm just going to call this let start B, and then I'm going to start at the first character at A, and then let finish B str char code at, and now we want the last character in the string, and to do that, to get that index, I'm going to use str.length -1. Okay, so this is how we get the code for the last element in the string. Let's console log this so we can see better what we are doing. Start, finish. Okay, 97, 101. Okay, cool. Now I want to iterate through all the letters from the code 97 to 101. Okay, how can I do that? I'm going to create a for loop. I'm going to start I at the start. I'm going to make I smaller than equal to finish, and I'm going to increment by 1 because the codes always increment by 1 from A to B to C to D. Okay, let's remove this console log here. Let's try to console log what we get. Console log, and now I want to convert the code into a character. Okay, and for that there is a method in JavaScript string dot I have to check that. So that method is from char to code, and it's going to be I is going to be the code. Okay, from char code. So here we see that we have A, B, C, D, E printed because we're going through from the start code of A until the E, and we also have D in this case. Now to find the missing letter in the string, we can just check through each iteration, check with the first element in this in the first iteration, the code will correspond to the first, should correspond to the first element in the string, and then the second in the second iteration, the code should correspond to the second letter in the string. And if we find an iteration where the code doesn't correspond to the letter, then we find that a missing letter. Okay, we can do something here. So I'm just trying out something with console log. Now I want to get the element with the correct index. So str.i minus start. Why am I doing I minus start? Because I want to get the index 0 in the first iteration, and since we start I at the start number, and this one will give me 0 in the first iteration and 1 and 2 in the next ones. Okay, so this will give us the letter for that iteration, and we want to check if it's equal to this one. Okay, let's try that. Let's call this let code. I'm going to call this code letter, and this one let str letter. Okay, and now I want to check if this is equal. If code letter is equal to str letter, or better, let's just check only the case where it's different. So we want to check if the code letter is different from the string letter, then that code letter is the one that is missing. Okay, so if that is the case, then I just want to return that code letter. I'm going to remove this here so that it returns undefined if this one runs. So when we go through the loop, if we cannot find a code letter which is not equal to string letter, then it just returns undefined. That means that all the letters are present in the range. Let's console log what this already does. Okay. Yep, it gives us D. I think let's run this. I think this should work. Yeah, perfect. Okay guys, that's it for this video. In the next one we will continue with sorted union. Thanks again for watching, and I'll see you in the next one. Hey guys, welcome back. We will continue with intermediate algorithm scripting, today with sorted union. We need to write a function that takes two or more arrays and returns a new array of unique values in the order of the original provided arrays. Okay, so in other words, all values present from all arrays should be included in their original order, but with no duplicates in the final array. And the unique numbers should be sorted by their original order, but the final array should not be sorted in numerical order. Here are some examples. So if we have two arrays, one is 132 and 5214, and then another one 21, the final array should be 13254. Okay, so we should get the union of the arrays, but not sorted numerically at the end, only with the order of the arrays they belong to in the beginning. Okay, so this one should return 13254. Okay, since we don't know how many arguments the function will have, I think we should use the arguments object. Let's try that. Console.log what that prints. Okay, and that gives us an object with all the arrays as arguments. There's a method in JavaScript, array.from, from which you can construct the array, in this case, from the arguments object, and it gives us a nested array, a 2D array. Let's assign that to, I'm going to call this all R for all arrays, and I'm going to declare it. Okay, let's console log this. Okay, so but to be able to process it better, we need to flatten it, to put everything into one array. So we need to concatenate all these arrays inside. I think we should use the reduce function method. So I'm going to do a reduce, and I'm going to give a function inside which takes two arguments, a and b. A and b should be a.concat. B should be just arrays. So it is reducing this array of arrays into a single array with all the sub-arrays concatenated. Let's make this more descriptive. I'm going to call this R1. So, and B is going to be R2. And we want... So we are simply concatenating. That's what reduce is doing. So now we have all the elements which we give as arguments into one single array. Let's declare a final array, the one we want to return in the end, the unique array, the unique values, or maybe let's call it union array. Let's declare it as empty, and now the easiest thing we can do is just iterate through all array and check if the element already exists in union array. If not, we just push it. That's pretty straightforward. I'm going to remove this. So I'm going to make a for loop, or let's just use for each. I'm going to iterate through all array for each, and inside I'm going to put a function which just takes an element, and what this does is if it just checks if element is already in union array. So if union array contains element, or we want to check if it doesn't contain it. That's the thing we are mostly interested in. So if it doesn't contain it, we just push it into union array. An array.push element, and let's put, okay, so we are iterating through all the elements inside all array. If the element doesn't exist in the union array, we just push it, so we make sure to have no duplicates. And in the end, we just return the union array. I think this one should do it. Let's not contains, includes. Sorry, I confuse the syntax of JavaScript sometimes. Let's see. Let's do a console log here. Yeah, I think this one works. Yep, this works. Let's run the test. Perfect. Okay, guys, that's it for this video. In the next one, we will continue with the next exercise. Okay, thanks for watching. Don't forget to subscribe to support the channel. I'll see you in the next one. Bye bye. Hey guys, welcome back. Today we're going to solve another intermediate algorithm scripting exercise. It's called convert HTML entities. Okay, so this will be like a bit of HTML parsing, how it happens behind the scenes. We need to convert the characters, this and, smaller, greater, a double quote, and apostrophe, in a string corresponding to their HTML entities. And we have examples here so we know what to use. So this will be the entity for and, using the and symbol and ampersand, I think it's short for, and semicolon. Okay, so we have some HTML entities which we can represent them as string, and we need to basically map all of these characters into their corresponding HTML entities, which are strings by themselves. The best way is to create an object where to store all these entities, all these characters as properties, and the corresponding HTML code as a value of type string. Okay, so let's do that. I'm going to create inside the function here a const. I'm going to call it entities, and it's going to be an object. The first is going to be the and symbol, and the corresponding HTML code is this one. Okay, and we will do the same for every character. Let's just copy this so it's easier. Or 5 we need. Okay, now for smaller we need to use, this is the HTML code for sorry, this is less than, and this is greater than. You can find I'm getting all of this from the examples. Okay, so here is the example for greater than. And for double quotes, I'm going to use an escape character, and this is quote. For apostrophe, this is apos. Okay, so this object now we have as key values all the characters and their corresponding HTML code. Now I think the best thing we can do is to split the string into an array of characters and go through each character to see if it is one of these and map it into the HTML code. Okay, first let's just create an array of characters. So let array is going to be str.split, and we're going to split it by character. So let's see what this does. Okay, now that we have an array, we can just map. We can use map to iterate through all of them. And what we want to do is that let's write the function. It's going to be a function which takes an element Okay, I'm going to move this a little bit like this. Okay, so now it takes an element and it checks if this element is one of these, then it is going to convert it, and then it is going to, yes, to map it into the HTML code. Okay, so if I'm going to check by using the object has own property, if entities has own property with the name element, what we want to do in this case is return the entities element. Okay, so we are mapping it into this one if it's this. Else we just want to return the element just like it is. This will be, for example, for DO, for all the letters, all the other letters which are not these special characters. Okay, I think this is the easiest way to do it. Let's see what this does, and as you can see, it converts everything we want, only the things we want to convert. And now, since we need to return a string, we can just do return array.join, and again we're going to join every character together. Let's remove this console log and see what this does. Yep, I think this works. Okay, let's run it, run the tests. Okay, perfect. Okay guys, that's it for this video. In the next one we'll continue with some all odd Fibonacci numbers. Okay, thanks again for watching. I'll see you in the next one. Don't forget to subscribe. Bye bye. Hey guys, welcome back. So today we will continue with another intermediate algorithm scripting exercise from freeCodeCamp. It is the sum of all odd Fibonacci numbers. Okay, so we are given a positive integer num, and we need to return the sum of all odd Fibonacci numbers that are less than or equal to num. Of course, the first two numbers in the Fibonacci sequence are 1 and 1. Every additional number is in the sequence is the sum of the two previous numbers. So the first 6 would be 1, 1, 2, 3, 5, and 8. And sum fibs 10 should return 10 because all odd Fibonacci numbers are less than or equal to 10 are 1, 1, 3, and 5. Okay, great. So let's get started. I want to store to have two variables, a and b, to store two consecutive Fibonacci numbers. So I'm going to start them at 1. Let b be 1. So a and b are two consecutive Fibonacci numbers. I want to also start the sum. That sum, let's start it at 0. This is where we will store the sum of all odd Fibonacci numbers smaller than or equal to num. Okay. Now we will want to create a loop where we want to compute Fibonacci numbers and compute the sum. So the best thing I think we can do is a while loop. And in the while loop we will have the condition that the Fibonacci number b, so b will be the second in the sequence AB, so it will be bigger than A. We want B to be less than or equal to num. Okay, so this is the condition for the while loop. Now, what we want to do inside is that let's compute the sum. So for the sum, I'm going to add B to the sum. I'm going to increment it by B. So we add all the Fibonacci numbers. Okay, but to start this, I think we should start the sum at 1. So the sum is equal to A. So we have added A to the sum. And now we will continue with B, and on each iteration, B will be the next Fibonacci number. Okay? So we will increment it by B, the sum, and now we want to compute the next Fibonacci number. So the next Fibonacci number will be, so B will be A plus B. Okay, because the Fibonacci number is the sum of the two previous Fibonacci numbers. Now I want B to be A plus B, but we also A should be the old B. Okay, and to do that, okay, the easiest way is to create a temporary variable where I store B, and after I compute the new B, now A will be the old B. Okay, so we still have two consecutive Fibonacci numbers, which helps us compute the next one. That's why we need to store to have A and B as well. But in here, when we do the sum, we just add the new Fibonacci number. We don't need to do A plus B because we will be adding a Fibonacci number twice. Okay, I hope that's clear. I think this one now does all, and we need to return the sum. Let's see what this does. Okay, oh, okay, I forgot something. We need to add only the odd Fibonacci numbers. So I will do the sum only if B percentage 2 will be equal to 1. So this means if B divided by 2 gives 1 as a remainder, then I will do the sum. Okay. Now I think, okay, this one should return 5. Why is it just returning? Okay, we start A at 1, B at 1. We start sum at 1. And now we do this. Temp. Ah. Okay. This is a bit strange. Now, okay, I think now I saw this. I created a temporary variable, but I never used it, okay? So I think now it gives us the correct answer. And let's run the tests. Yeah, perfect. Okay, guys, that's it for this video. I'll see you in the next one. Okay, thank you for watching. Don't forget to subscribe. Bye bye. Hey guys, welcome back. We will continue with another intermediate algorithm scripting exercise, sum of all primes. Okay, let's get started right away. A prime number is a whole number greater than 1 with exactly 2 divisors, 1 and itself. For example, 2 is a prime number because it is only divisible by 1 and 2. In contrast, 4 is not, since it is divisible by 1, 2, and 4. So we need to rewrite this sum of primes that it returns the sum of all prime numbers that are less than or equal to num. Okay, the best way I think is to make a helper function isPrime to check if a number is a prime number or not. So I'm going to do that right here. I'm going to define a new function isPrime, and let's have x as an input. We don't care. Now we want to check if it is 2. 2 is a special case, I think. So let's make it if x is equal to 2, just return true. Okay. If not, then I think we should go make a for loop where we go through all the numbers from 2 to go through all the numbers from 1 to the number x we want to check, so that we find that there are no divisors except 1 and itself. Okay, so I'm going to make a for loop. I'm going to let I think it would be clearer with code. Well, now that I think of it, we should start from 2, and then I should be less than or equal to x and I++. So we will go through all the numbers from 2 to x and check if they are divisors of x. Okay, if x modulo I gives us 0, that means that it is a divisor, then we immediately want to return false. And not equal but smaller, because okay, this one should cover it. So if we have a number bigger than 2, because 2 is covered right here, 3 for example, we go through 2 and 3. And if so if we go through 2 and 3, it will return false immediately, because 3 modulo 2 will give 1 and not 0. So yep, so it won't go into this one, and then it will check 3 modulo 3 won't be checked, so it will go through all this and not return false. Sorry, we should return true for 3, because 3 is a prime number. So let's make it return true. Okay, once again, if it is 2, immediately return true. If it's larger than 2, then check if there are any divisors other than itself and 1. Since we are excluding 1 and itself, if there is a divisor between 2 and x, then we return immediately false. I think this one should work. Let's just check if it is working. For example, console log is prime 7. Yeah, okay, it is true. Let's take 10 and false. Okay, 11 is prime. Yep. 12 is not. Okay, seems to be working fine. Now we want to take the sum of all prime numbers smaller than or equal to num. Let's declare the sum here. A variable initialized at 0. And now I'm going to iterate. I'm going to start I at 2, because we don't consider 1 by definition. I should be smaller than equal to num and I++. What we want to do in this case, we want to check if I is a prime. If is prime I, then if it is true, just add that number to the sum. So we make sure we take the sum of only prime numbers. Okay, and in the end, we just return the sum. Yep, this one should do it. Let's try console log here. And 17. Great. Let's run this. Make sure to look at all this code. Okay, perfect. Okay guys, that's it for this video. In the next one we will continue with smallest common multiple. Okay, I'll see you in the next one. Thanks for watching and don't forget to subscribe. Bye bye. Hi guys, let's continue with intermediate algorithm scripting. So I think today we will do smallest common multiple. We need to find the smallest common multiple of the provided parameters that can be evenly divided by both as well as by all sequential numbers in the range between these parameters. So the range will be an array of only two numbers that will not necessarily be in numerical order. For example, given 1 and 3, find the smallest common multiple of both 1 and 3 that is also evenly divisible by all numbers between 1 and 3. Okay, so the answer here would be 6. 1, 5 should return 60. Okay, I think the best way to do this, again, is to create a helper function. I'm going to create a helper function which just computes the smallest common multiple of two numbers. Okay, I'm going to make this an helper function compute SCM, and this one takes two numbers, num1, num2. Now, what we want is that we want to know which number is the largest. Okay, because we might give number 1, so we don't have to give the numbers in orders to this function, so we need to do something inside the function to get the largest. So I'm going to do something like this. I'm going to make sure that a is math.min, and I'm going to give num1 and num2 as argument. So this is a function in JavaScript to get the minimum of two numbers. And I'm going to do b, going to be math.max of num1 and num2. Okay, so now we are sure to have a the smallest and b the largest number. Now, to get the smallest common multiple of the two numbers, we can do something like this. This is the easiest for me, we can start with b, which is the largest number of the two, and we start computing multiples of b, starting 1b, 2 times b, 3 times b, until we get a number that it is also a multiple of a. And if we cannot find, we need to go only to a and b, so we need to go only a iterations to find it at maximum. But somewhere in the middle we might find some number, for example 3b, which might be a multiple of a as well. Let's write the code. I think that would make it more clear. So I'm going to make a for loop, and I'm going to create a variable m, which will be the multiple, and I'm going to start it at b. Okay, now I want m to be smaller than equal to a and b, because a and b will be, of course, a multiple of both a and b, so that is that is sure, of course, but we want to find if there is something smaller than a times b. Okay, and now we want to increase m, not by 1 but b, so we want to get 1b, 2b, 3b, so I'm going to do m is going to be plus equals b, which means that m is equal to m plus b, so in each iteration we add 1b. Okay, and I'm going to make the shortened version of this. Okay, let's go through the loop. What this does now, what we want to do is we want to check if this number m is also a multiple of a. So I'm going to check if this is equal to 0. Okay, m modulo a. And if it is, then we have found the multiple. We just return m. Okay, I think that's it. So with this way we will make sure to find the multiple of a and b, the smallest common multiple. Let's try this function. Do console.log here, and I'm going to call compute SCM and I'm going to give, for example, 2 and 5, and it gives 10. Of course, that's correct. 2 and 10 gives 10. 2 and 25 gives 50. 5 and 25 gives 25. Okay. 12 and 25 gives 300. Okay, this seems to be working fine. So we have a function to compute the multiple of two numbers. But now we want to compute the smallest common multiple, not of two numbers, but an array of numbers, starting from a number until another. Okay, so this array again will be, we will have an array of only two numbers, so 1 and 5, but we don't know which one is the smallest. So again, inside here, I'm going to do something like this. I'm going to make sure I have a number x be math.min, and I'm going to give this, use the spread operator for the array, and I'm going to use y be math.max. Okay, so now we are sure to have x is the smallest and y is the largest, and we can start the array from x until y by incrementing by 1. Okay, now let's remove this return. What we want to do is to let's declare an SCM here, and I'm going to start this SCM with a value of 1 to initialize it. Now I want to create a for loop that I be equal to x, and I'm going to make sure it is smaller than equal to y and I++. Okay, so we go through all the numbers. Now what we want is we want to always compute the smallest common multiple between the two numbers, between I and the SCM we already have. So SCM will be compute SCM, and we give SCM which we previously had an I. Okay, so in each iteration we will get the SCM of the two numbers, and when we finish iterating, when we go through from ix until iy, I think we should have the smallest common multiple of all the numbers, even the ones in between. Okay, let's try this. Maybe I am missing something here, but let's try it. Okay, let's do the console log. Okay, 1 and 5 should be 60. Yep, it's working. Let's try with 2 and 10. 2 and 10 is, yep, okay, it's working fine. So remember that SCM is always getting computed, and we are using the last SCM version. So when we do the SCM of the first two numbers, then we do this SCM with the third number, and then with the fourth number, and we make sure we always have the smallest common multiple of all the numbers we have seen so far. Let's run the tests. Yep, perfect. Okay guys, that's it for this video. We will continue in the next one with this drop it exercise. Thanks for watching. Don't forget to subscribe. I'll see you in the next one. Bye bye. Hey guys, welcome back. So today we will solve the exercise drop it from intermediate algorithm scripting in freeCodeCamp. Before we get started, make sure to hit that subscribe button. Okay, so we are given an array, and we need to iterate through and remove each element starting from the first element at the 0 index until the function func returns true. So when the function returns true, then the iterated element is passed through it, and we just need to return the rest of the array once the condition is satisfied. Otherwise, array should be returned as an empty array. Okay, let's see. we need to just go through this array, and as soon as this function returns true, then we just return the rest of the array. Okay, I think there's a short and very clear way to do this. What we can do is make a while loop, okay, and the boolean and the condition in the while loop should be that function of array at 0 should return false. Okay, and if it returns false, we just remove from that array that element. So we are going through the array and we are always getting the first element. So let's see, in the first iteration we get the first element. If this one returns false, which means this function returns false, then the condition is true because we put this negate here. What we want to do in this case, we just do array.shift, which just removes the first element, the element with index 0 from the array. And after it removes that element, then we again, in the next iteration, we will get the element with index 0, which will be the second element in the original array. Okay? So let's see what this does. Okay. Let's test it with 1, 2, 3, 4, and the function means n is bigger than or equal to 3, and this one returns 3, 4. I think this one is working. It's pretty short, but it's working. So just to make sure you look at the code so you can understand everything. Right here, we will always get the next element. If we keep shifting, the element at index 0 will be a different one because the array will be shrinking by removing one element at the top. Okay, I think this one does it. Maybe here we need to add another check that the array isn't empty, because if it is empty, then we might get an error, or we might go into an infinite loop. So let's do another check here. Array is diff arrays.length is bigger than 0, and we do end here. Okay, I think this one should do it. Let's see, let's run the tests. Yeah, perfect. Okay guys, that's it for this video. I'll see you in the next one. Don't forget to subscribe. Bye bye. Hey guys, welcome back. We will continue with another intermediate algorithm scripting exercise. This one is called Steamroller, and all we need to do is flatten a nested array, but we must account for varying levels of nesting. Okay, so here are some examples. Like this one should return 1, 2, 3, 4. Okay, so this is a bit complicated, but I think we need to use recursion on this one, because we don't know how many levels of nesting will be, so we want something to be calling itself whenever it's needed. Okay, I think it will be more clear when we write the code. And let's get started right away. Now we want to iterate through the elements of this argument. The argument will be an array in itself, so let's just iterate through them. Let I equal to 0. I think there might be a better way to iterate in JavaScript using some in operator, but doesn't matter, it's the same thing, just a little bit more of code writing. Now what we want to do here is we want to check each element if it is an array or not. Okay, and for that there's a ready function in JavaScript called array.isArray, which belongs to the array object, and we can write something like this: if now array.isArray, and inside we just put an element of this array, and we check if this one is as well an array. Like, for example, in this case it would return true, also in this case. Okay, we need now right here we need to do something. We need to call the recursive function, but let's leave it for a moment and write the base case. So if it is not an array, what we want to do is just push it into, let's create, or maybe call it var, because we wanted to modify it, flat array. So I'm creating an empty array, a flat array, where I will put all the elements. So in the base case, I just want flat array dot push ri. Okay, so this is the base case. So if it is not an array, we just push it right away. But if it is an array, now we want to call steamroll array again. And right here we return the flat array. So what we want in this case is to just call again the steamroll array for this. So we call the recursive function for each array. If it is again an array, we go again even deeper into the levels of nesting. And we just right here we do flat array to be steamroll array, and we want to give array I. Okay, let's do a console log here. Now there might be something not working, right? Okay, first thing that is not working is that this flat array needs to be outside, needs to be a global. Okay, let's write this like this. And we have 1, 2, 3, 4, but we have all these undefined, which we don't need. Where is this happening? Okay. So right here we have something. So where are all these undefined coming from? Okay. We want, oh, yep, everything seems to be fine. Let's see. Okay, I saw it's just an error in the iteration. We don't need this equal because I was getting more element than there was in the array. Okay, so this one seems to be working fine, but we are using this flat array as a the scope of this is global, so we modify always this flat array. Now if we don't want to put this here, we can just do something like this. We can declare it as an argument of the function, and that takes a default value. Let's try to write this like, okay. And now when we call the recursive function, we just give again flat array. and that does the same. Okay, so this is the code, and we're using recursion. Let's run the tests. Okay, perfect. Okay guys, that's it for this video. I'll see you in the next one. Don't forget to subscribe. Bye bye. Hey guys, welcome back. So we will continue with binary agents from intermediate algorithm scripting. So this exercise is pretty straightforward. We have a string of a binary string, and we need to convert it into an English translated sentence, and the binary string will be space separated. Okay, so we have all these bytes, okay, and we should translate it into this. Okay, so each byte here is storing one character, which is in ASCII code. So first thing we need to do is we need to take the string and split it into strings by the space. So we have an array of strings, and each string stores only one byte, one character. Okay, so we can do that with str.split, and I'm going to give the space. Let's do the console log here so we see what the output is. I'm making this smaller. Okay, console.log. Okay, great. So as you can see, we have this array now of strings, and each string is 1 byte, okay, or 8 bits. So now we have this in binary, and we need to convert it into an integer, but it will be the ASCII code of a character. Okay, so how we can do that? How can we do that? JavaScript has a method parseInt, which can help us. So let's try it only on one. Let's make a try here. I'm going to make console log, and I'm just going to take one of these strings, this one. I'm going to do parseInt the string, and now we want to give it the convention. So since we are converting from binary, the code for binary is 2. Okay, so it gives us the integer 65. So what this is doing is just taking a number which is into binary, the byte, and it is converting it into an integer with base 10. So we're converting it from base 2 to base 10. That's all this is doing. So this is so this number here is 65 with base 10. Okay, now that we have the integer, this integer represents the ASCII code for this character. Okay, and this should be the character A, uppercase A. And to do that, we can use the method in JavaScript, character at code, something like that. Let's try this. It's going to be string dot character at code at character, maybe, I don't remember. I'm going to check this. No, it is something else. Okay, so this is from char code. Okay, sorry, from char code. And as you can see, this gives us A. So each binary number here will be converted into an integer, which is the ASCII code, and then will be converted into the character, the string, so using the ASCII code. Okay, let's do this. Now we want to do this for each element in this array, so we're going to use the map. So now right here we have an array. Let's do the map. We will iterate through all the elements, and what we want is element to be mapped into string from what we did up there, char code, and inside I'm going to do parse int, and this is going to take as an input the string, which is the element, and 2, which is the base of the number. Okay, as you can see right here, we have all the characters, but we need to join them into a string. Okay, so after we have done the mapping, we can do just join, and we're going to join okay, we have the mapping. Oh, I think we are missing a parenthesis here, and remove this one. Yep, this seems to be working fine. Let's remove the console log, and we have it. So this is what is doing it all. We are splitting first, we are mapping every binary, converting it into an integer, which is the ASCII code, and then from char code to get the character. Okay, and then we are joining all the characters together into one string. Perfect. Let's run the tests. Yeah, great. Okay guys, that's it for this video. In the next one, we will continue with the next challenge. Thanks for watching, and don't forget to subscribe. I'll see you in the next one. Bye bye.
Hey guys, welcome back. So today we will solve another exercise. It will be everything be true from intermediate algorithm scripting. Okay, let's get started right away. The exercise states that we need to check if a predicate, which will be the second argument, is truthy on all elements of a collection in the first argument. So we are given an array, a collection of objects, and the predicate PRE will be an object property, and we need to return true if the value is truthy, otherwise returns false. So in JavaScript, truthy values are values that translate to true when evaluated in a Boolean context. Okay, this one seems pretty easy. All we need to do in this case is check every collection if it has the property PRE, and then if it evaluates to true. We can write this using every. If you remember, if you do this every, then you can use a function to check that every element in that collection should return true when applied to that function. Okay, so we don't have to write a for loop. It's easier to write every to iterate. Now, what we need to check, so we need to write a function right here, a fat arrow function. lm is going to be, what I want to check first is that the first condition is that element has the property PRE. So lm has own property and PRE. And the other thing I want to check, I'm going to use and here. I want to check that the value of the property PRE should be evaluated to true. We can access the value like this. Now, to evaluate it, we can put it in a Boolean object. It's pretty easy, like this. And I think this one should do it. So this function will be applied to every element in the collection, and it will return true only if it has that property PRE, and that the value of that is evaluated into true. So it is a truthy. Let's try it with this one, with console log. And let's see. Yeah, okay, this one evaluates to true. Seems to be working. Let's run the tests. Okay, that was pretty easy. Okay guys, that was a really short one. In the next video we will continue with arguments optional. Thanks for watching, and don't forget to subscribe. Bye bye. Hey guys, welcome back. So today we'll continue with another exercise in intermediate algorithm scripting. It's arguments optional. Okay, we need to create a function that sums two arguments together, but if only one argument is provided, then we need to return a function that expects one argument and returns the sum. Okay, here is the example with 2, 3 should return 5, and add together 2 should return a function. Okay, and we should be able to call this returned function with a single argument. If either argument isn't a valid number, return undefined. Okay, now let's start here. To check the number of arguments, we're going to use the object arguments. Let's see what that does. Yep, it just gives us an object with the arguments. We can it's easier to work with it if we convert it into an array, and we can do it like this: array dot from, I think this one converts it into an array. Yep, okay. Now I'm going to store this into a variable called args for arguments. So here we have all the arguments. Now we need to perform a check if args.length is equal to 1. Then if we have only one argument, we just need to return a function. And the function, we can just return the same add together function, but now it will have the args0 as an argument. And then we can add another argument. So this one should work. Okay. Now, or no, better we should do something like we should return only a function. Oh, okay. So in this case, this one wouldn't work. So we can write a function right here, a fat arrow function, which is easier. And we can do something like this. So it takes only one argument, x. And what we do is we do x plus add together args0. Yeah, I think, no, returns args0 and x. Yep, this one should work because now we are applying add together with two arguments. And this one we will specify right here. Okay, so if it is only the length 1, else will cover only cases with length 2, because yep, these are the only cases we want. Let's specify it, else if, or I think else should work. Now we want, when there are two arguments, we just want to return the sum. Return args0 plus args1. Okay, let's see what we need to remove this return. Let's see what this does. Okay, it works for 2. What about when we do something like this? Yep, it works. Now we only need to cover when the argument isn't a valid number, if either argument isn't a valid number. Maybe it's better to check that first. So I'm going to make this an else if, and I'm going to create an if here. Now, how can we check if either argument isn't a valid number? We can do, since we have an array of arguments, we can do args.sum. So as long as the function inside sum doesn't return true for any of the arguments, then it will be false. Okay, so if args.sum, and we want to check if element, I'm going to write a function here, we want that to be not a valid number. So type of element should be different from number. Okay. Yep, I think we can do it even with every, but we just need to write equals to number. So in this case, if any of these elements in the array is not a number, then this one will return true, and it will go inside. It will execute this block of code. And what we want in this case, we just want to return undefined. Okay, and this is the else if. I think now we cover all the cases. Let's run the tests. Yeah, perfect. Okay guys, that's it for this video. In the next one we will continue with make a person. Thanks again for watching. Don't forget to subscribe and hit that bell notification icon. I'll see you in the next one. Bye bye. Hey guys, welcome back. We will continue with intermediate algorithm scripting, and today we're going to solve make a person. Okay, what we need to do is to fill in the object constructor with the following methods: a get first name, get last name, get full name, and then set first name, set last name, and set full name. We need to run the tests to see the expected output for each method, and that the methods that take an argument must accept only one argument, and it has to be a string. Okay, so let's get started right away. Here we have a getter method for the full name, so we just need to modify this one, and inside the get full name we just need to get the full names and return it. So in here I'm just going to return first and last. First and last is taken as an argument by the constructor to start creating an instance of person. Now this return in the constructor we don't need it, because we are going to use the getter. Okay, so this one now should work. Let's do a console log. Okay, right here. Okay, great. Now we have to do get first name, get last name. I'm just going to copy this. And this one is get first name. I'm going to make a function, and now to get the first name, as you can see, the first name, we can split this string and get the first element. So get first and last dot split. I'm going to split by the space, and I'm going to get the first element. Let's see what this does. I'm going to test it right here. Yep, it just gives us Bob. Perfect. Now I'm going to do get last name. Okay, and I am splitting again, but now I'm getting the second element. Okay, so let's try this. Yep, it's giving us Ross. Perfect. What we need now is to do the setter. Let's do set first name. I'm going to copy this and change it. So again, we're going to do this set first name, and this function takes an argument first. Now, what we want to do in this case, we don't want to return anything. We just want to change the first name in the first and last. Okay, so how can we do that? First, we can construct first and last again, but now we're going to use first that we have taken as an argument. So we can do this. First and last now is going to be equal to first plus first and last, or we can get the last name. We are putting the new first name, and we just get the first last we get the last name using the method, the getter. This dot get last name. Okay, now this will be the new first and last. Let's try this. So if we do set first name, and I'm going to give a new Jim. Okay, now I don't want to console log this. Now let's console log bob.get
full name. Okay, as you can see now that's Jim Ross, but we need to add a space here. So I'm going to do this. Okay, Jim Ross, perfect. This is how I set the first name. We'll do the same for last name. And now here I'm going to do set last name. We'll take last and we just do the opposite. In here we do this dot get first name. We get the first name. We add the space, and then in here we just add last. Okay, let's try to set the last name as well. Set last name Jim Hawk. Okay, Jim Hawk. From Bob Ross, now we changed it to Jim Hawk because we changed the first name and the last name. Now we need to do set full name. This is much easier. We can just do, let's make some spaces here to make it look cleaner, at least for me. Okay, now this dot set full name. Make sure to also review object-oriented JavaScript for this. And I'm going to take first and last as an argument. And this can be just, I can just reset it like this. This should work. Let's try Bob. So I'm going to do here another reset, Bob dot set full name, and I'm going to give John Smith. And now console.log bob.get full name is giving, oh wait, this one isn't working. We need to do set full name. Okay, function, okay. Right here we can try something else. I think there's a confusion with the variables. Wait, let's make it more clear. So I'm going to make it so that it takes full name, and then right here full name. Okay, perfect. Okay, now this should work. This is all the code we wrote. Let's run the tests. Get first name is not working. Oh wait, maybe we should remove all of this. Okay. Okay, perfect. It was because we made the changes to the object. Okay guys, that's it for this video. In the next one we will do the last exercise for intermediate algorithm scripting. Don't forget to subscribe, hit that bell notification, more videos are coming. Thanks again, and I'll see you in the next one. Bye bye. Hey guys, welcome back. So now we will solve the last problem in the intermediate algorithm scripting. This one is called map the debris. Okay, so we need to return a new array that transforms the elements average altitude into their orbital periods in seconds. Okay, the array will contain the objects in the format name and average altitude as properties. You can read more about this on Wikipedia. The values should be rounded to the nearest whole number, and the body being orbited is Earth. The radius of the Earth is here 6,367 kilometers, and the GM. Okay, now we are going to use the formula to compute the orbital period in seconds. But what we want to do in this case is we're going to iterate through a list of an array of objects, and we're going to compute the orbital period. And to do that, the easiest way is to use map. I'm going to do array.map, and inside I'm going to define a function which takes an element and now does some things for us. Now, first thing we want to do is to compute the orbital period, and we're going to use the formula for that. You can check it on Wikipedia or wherever you go. Now, let's construct the formula bit by bit. So first, I'm going to, again, you can check this on Wikipedia. I'm just following the formula. Now, I'm going to use the Earth's radius, plus the average altitude. So lm.average altitude. Okay, and this one should be cubed, so I'm going to use math.power, which allows you to put things into power, and I'm going to put it into power of 3. This one will be divided by the GM. Okay, and all of this should be square rooted math.sqrt. Now everything here should be multiplied by 2 pi, 2 times math.pi times this. Okay, now this one will be assigned to a new property called, let's just call it the orbital period. Okay, and to assign a new property, we just use the dot notation or the bracket notation, whatever comes easier to you. lm.orbital period is going to be this one. Okay, so we change the element, and in the end we just want to return the element here inside the mapping function. Let's see what this does for us. Console.log, and as you can see, it has computed it. Oh, we want to round it. Okay, so I'm going to use math.round. I'm going to put everything here into parentheses again, and I'm going to use math.round, and now we get this nice whole number. Okay, but we are not finished yet, because as you can see, we want to remove the average altitude as a property. Okay, so we just compute the orbital period and we leave only that, and we delete this as a property. That's pretty easy. We just use the keyword delete element dot average altitude. Now I noticed I have misspelled orbital here. Okay, perfect. This is what we want in this case. Let's run the tests. Perfect. Now guys, we're finished with the intermediate algorithm scripting. In the next videos, I will try to go through the projects for this freeCodeCamp curriculum. Okay, so thanks again for watching. Don't forget to subscribe, and many more videos are to come. Thank you again, and I'll see you in the next one. Bye bye.
Hey guys, welcome back. So today we will continue with the projects for the JavaScript algorithms and data structures in the freeCodeCamp curriculum. Okay, let's get started right away with the first one. This is palindrome checker. Okay, and now let me set this. Okay, so we start from scratch. Okay, now what we need to do is to check if a string is a palindrome. Okay, a palindrome is a word or sentence that's spelled the same way both forward and backward, but we need to ignore punctuation, case, and spacing. So we need to remove all non-alphanumeric characters. Okay, so before we check if it is a palindrome, we should do some cleaning up first. And the best way, I think, is to use a regular expression. It's pretty easy in JavaScript. Let's try something. I'm going to do str.replace, and as a first argument you just give a regular expression of the things we want to replace. Now here we will write the regular expression. Since we have a lot of types of characters which we don't want, it's easier to write the things that we don't want to, that we want to keep, and just add a negate so that make sure that the regular expression finds everything but these ones. Okay, it will be easier when I write the code. So we want to keep all the alphanumeric characters. Okay, so we want, and first let's make them all lowercase. Okay, since we don't care for the uppercase, lowercase. Let's make it 2 lowercase. That's pretty straightforward in JavaScript. Now, after we've made the string lowercase, we want to replace. Now, I'm going to do A to Z and digit. Okay, so this means only alphanumeric characters, and we don't care for the case. But we want to keep alphanumeric characters, and we want all others to be removed. Okay, so I'm going to add this to negate it. So using this means that we want to find, with this regular expression, all characters which are not alphanumeric from A to Z and not digits. Okay, and now since we just want to remove them, we can use replace and just replace it with an empty string. Okay, so this one should do the trick. And to find all of them, I'm going to add this G flag at the regular expression, which means globally, to find everything and replace it with an empty string. Let's try to print the string and see what we have done so far. I'm going to add some stuff here. Okay, this one is not working at the moment. We need to, I think we need to save it into a new string. I'm going to make this a new string. New str is going to be like this. And right here, I'm going to print the new str. Okay, perfect. Yep, so this is the new string, which is cleaned up of all the non-alphanumeric characters, and it's made all lowercase. Okay, I think this one was the hardest part to come up with this regular expression, because now, since we don't have any other constraints, to check for a palindrome, we just do the reverse and check if the reverse of the string is the same as the string that we already have. Okay, and the easiest way we can do that is we can just check new str. I'm going to split it, since we cannot reverse string directly in JavaScript. We need to split it into an array of characters. So this one does that. After we split it, we do the reverse. Okay, and after reversing it, I'm going to join. Let's see what this does. I'm going to console log. Okay, it does reverse and join, but let's try that. Yep, okay, it does what we want. Now we want this to be equal to the new str. So if this is equal to new str, then it means that we have a palindrome here. And in this case, we really do, because we are ignoring all these other characters. Okay, I think this one should work on all of these. Let's run the tests. Yeah, perfect. Okay, guys. I think that's it for this video. It was a pretty straightforward solution. In the next one, we will continue with a Roman numeral converter. Okay, thanks again for watching. Don't forget to subscribe. I'll see you in the next one. Bye bye.
Hey guys, welcome back. Today we will continue with another JavaScript algorithms and data structures project. This is the Roman numeral converter. Okay, so what we need to do is we need to convert the given number into a Roman numeral. All Roman numeral answers should be provided in uppercase. Okay, so if we get 2, we should return 2 i's, 3 i's. Okay, you remember maybe Roman numerals from school. Now, before we start writing the code, to save up some time, I have already copy-pasted this object I wrote. Okay, I'm going to go through this right away. So inside the function, I am just pasting this const, and it's an object called numerals. And what I am doing here, I'm basically creating a table of conversion. So 1 is the property of the object numerals, and I as a string is the Roman numeral value. Okay, so we have key values for everything. I created this so we have this in handy, so we can use it for converting decimals into Roman numerals. So just make sure to create this as well. You'll have to type it. Okay, so it's just an object with properties which are numbers, and values which are strings and Roman numerals. I have only taken 1, 4, 5, 9, 10, 40, 50, 90, 100, 400, 500, 900, and 1000, because the others we can construct using these. Okay, so we need only these to construct every Roman numeral. Now, what we need to do is we need to start from the last the largest Roman numeral, which is 1000, and for every number we get, we check first if there are any thousands, if there are any hundreds, and so forth. Okay, so let's make a list for let's make an array with only the keys of these object numerals and reversed, so we get the largest first. And to do that, I'm just going to create let's make this const. I'm going to make this now these are the keys, so decimal keys, I'm going to call it, of numerals. Okay, let's make this larger and better. Okay, now to do that we are going to use object.keys, and the name of the object is numerals, and I want to reverse this because now this is an array. Let's console log this. Keys, and as you can see, we have right here printed an array with the values. Okay, now what we want to do is also let's declare a string. So this will be let Romanized, and let's start it with an empty string. So this is the initial Romanized version of the number we get. Okay, now we just iterate through all the decimal keys starting from 1000, and to do that I'm going to use for each keys dot
For each, and inside I can iterate through all the elements, and I'm going to call this maybe a key, and this one should do something like this. Okay, let's put it into this one. Okay, now what I want to do in the first one, I will have 1000. So in the first iteration, now I want to check if the number I'm getting is larger than 1000. If it is, I'm going to add one m to the Roman numeral. Okay, and then after that I will remove 1000 from the number, If the number is still more than 1000, I'm going to add another m and continue to remove 1000 until we get that that number is no longer larger than 1000. Then we will continue with 900. Okay, so for that I want to do a while loop. Now to access okay, so we have the key. We want to check if the number while or maybe while key is smaller than equal to number. What we want to do is just adding to Romanized. I'm going to add that Roman numeral, which we can access using the object property. So the object in this case is numerals, and using bracket notation, key. Okay, so I am adding, so if the number is 3200, then I am adding an m. And after that, I'm going to remove from the number that key, which is 1000. So then it is left over 2000. 2000 is still 2000 is still bigger than the key, which is 1000, and we keep adding another m until we are done. And when we are done, we go to the next iteration of the decimal keys, which is 900, and we add CMs if that is true. Okay, this way we keep updating the Roman numeral. I think this one should do the job. Now we need to return the Romanized. Let's console log this. Okay, this is what we want for 36, 3x's and VI. Perfect. I think this one does it. Make sure to write all the code, and let's run the tests. Okay, perfect. Okay guys, I think that's it for this video. In the next one we will continue with Caesar cipher. Thanks for watching. Don't forget to subscribe, like the video, share the video if you find it helpful. Thanks again. I'll see you in the next one. Bye bye. Hey guys, welcome back. So today we will solve Caesar's cipher. It is simply a shift cipher, and a modern use is the rot 13, which means rotate by 13, where the values of the letters are shifted by 13 places. For example, A goes to N, B goes to O. This works for the English dictionary, which has English alphabet, which has 26 letters. Okay, so 13 is the half of the number of letters in the English alphabet. Now we need to implement rot 13, which takes rot 13 encoded strings as input and returns a decoded string, and all letters will be uppercase. We shouldn't transform any non-alphabetic characters like spaces, punctuation, but we need to pass them on. Okay, first let's make a string with all the letters in the English alphabet that we want to check. So let's put every character. I'm going to create const alphabet, and I'm going to put everything in uppercase here. So A, B, C, D, E, F, G, I, J, K. Let's see if I remember. T, U, V, X, Y, Z. Wait, I forgot W. Caps lock. Okay. Okay, so we want everything in here. We will use this string later on. Now, let's see if I have everything. I'm going to do console log alphabet.length. Okay, 26, perfect. Now, we need to go through the letters in the string and do the rotation for everyone. Okay, so what we can do here is first let's create a new string, which will be the string we will be constructing by rotating 13 on every letter. So I'm going to do that new str, and this is going to be an empty string. Okay, now we need to iterate through all the characters in the string we are getting, like this one, and checking and doing the rotations. Okay, checking if it is an alphabet letter. If it is a space, we don't do anything, we just pass it on. Okay, and we add it as it is to the new string. Oh, okay, wait, I noticed that I should put W behind V. Okay, perfect. Now, how do we iterate through all the characters in the str? We just create a for loop. I'm going to create let I, I'm going to initialize that 0. I is going to be less than str.length, and of course I++. Okay, now I want to check if the letter in the string in str is in the alphabet, so if it is an alphabet letter. Okay, and I can do that by accessing the letter like this, so I can access the letter with the bracket notation. So here we are accessing the letter, and now we can check for this str with index I if it belongs in the alphabet string, and we can use the index of method. So let's try it here. Alphabet dot index of, and I'm putting here parentheses. As you can see, it's giving the index in the alphabet, okay, and the position. Where we get -1 is, I think, for the spaces, because it is not finding a space in here in this string, so it returns -1. Perfect, that's exactly what we want, a way to distinguish. So I'm going to make an if condition here. If alphabet dot index of, in the cases where it is it returns, it is equal to -1, then I just want to add it to the string, to the new string, just as it is. I don't want to do anything else. Okay, I'm going to add str I. Okay, now the else will cover the cases where we are dealing with a letter, okay, with an uppercase alphabet letter. Now we want to perform rot 13 in this one, so let's calculate the new index. So let new index. So the new index will be the index of the letter we want to replace this one, okay, after we perform a 13 shift. And this one will be by taking the number we already have, I plus 13, but we need to be careful because, for example, we might go to y, which should have index 24, and plus 13 is 37, which we don't have, then it will go out of range. So we want the sum plus 13, but we want to get the remainder by dividing by 26. Okay, what that means that if we get 24 plus 13, 37, and divided by 26, so we get the remainder is 11, and we need to go, where should 11 be? Let's just write the code and let it do the calculations for us. So the new index should be I plus 13, and I want to get the remainder by dividing by 26. Let's console log. Now this new index, I want to get the letter at this new index. So alphabet at new index. Wait, I have to use bracket notation. Okay. This is a bit weird. We're not getting freeCodeCamp. Wait, let me check. Yeah, of course. Wait. Um, the index here, of course, is not I, but is this one. Okay. So let's calculate this one. I'm going to do let index. Okay. And here I'm going to use this one. So this is not I, but index, because this is the index of the character in str, but we want the index where it is in the alphabet. Okay. So that's why it wasn't working. Now we have the new index. Okay, and as you can see, we're getting the letters here. Now what we want to do is we want to append this character after it is shifted 13 characters. We append it to the new str. So new str will be okay. Perfect. Let's remove all the console logs so it's not confusing. Okay. And I want to return new str here. Let's console log this one. Okay. Yep, I think it's working. Okay, so that's it. That's all we did here. We just iterate through the characters, check if it belongs in the alphabet. If it doesn't, we just add it as it is. If it does, we just shift it by 13. Okay, let's run the tests. Perfect. Okay guys, I think that's it for this video. In the next one, we will continue with the next project, number validator. Don't forget to like, share, subscribe to the channel to support this work if you find it helpful. Thanks again, and I'll see you on the next one. Bye bye. Hey guys, welcome back. So today we will solve telephone number validation. Okay, what we need to do is we need to write a function telephone check, which returns true if the pass string looks like a valid US phone number. Okay, so these are some examples that we need to accept. And we need to validate or reject US phone numbers. I think we should be using a regular expression for this one. This one might get a little bit tricky because there are a lot of cases we need to consider. So I'd like to use this tool regex 101, which is online. It's a website where you can go and test regular expressions. So I'm going to test there, and then I'm going to copy that regular expression in here and inside our JavaScript function. So I am going to switch to that website right now. Okay, so here are the numbers we want to grab, and this is one we don't want to grab. Okay, so right here I have configured for JavaScript, and I have set the flags for global and multi-line. Now let's start creating our regular expression. So first thing, we want numbers. This was the prefix, which is optional. It is in the requirements. So what we want in this case is I'm going to create a group for this one, and this one should be optional. So inside parentheses, I'm going to put 1 and backslash space. Now the space is optional. We can start with a space or not, and this group as well is optional. So I'm going to use the question mark. Okay, so this one should start, and then we should have 3 digits. Okay, let's have a group with 3 digits. I'm going to put it inside and to specify these for digits, for numbers, and I'm going to put a 3 here. Okay, so but now we should also cover the cases when this first group of 3 digits might be in parentheses. So we want cases with parentheses and cases without parentheses. So inside this group I'm going to use an OR. So I'm going to cover now the case with parentheses. And I'm going to do it like this. I'm going to use the escape character and the parentheses. So this one counts only as the parentheses. The character here is only to escape. Okay, and I want 3 digits. Okay, and I want to close the parentheses and close the yep. As you can see now we cover the cases with brackets as well. Okay, so these are the first 3 digits, which might be with bracket or without brackets. Now after this one we might have a dash, or we might have a space, or we might have nothing. So I'm going to create a group here. So we might have a dash or a space, which is \s, and now this one is optional, so I'm going to put a question mark, which means there might be 0 or more. Okay, so far we have covered the first 3 the country code, the first 3 digits, and then the dash, the space, or nothing. Now we want to go to the other group with 3 digits. So I'm just going to put here, well, actually we don't need to use a group in this case, because here we use the group for the OR. I'm just going to put 3 digits. Okay. And now, after this one, we want again a dash, or maybe a space or nothing. So I'm going to copy this part here. Okay. It's the same. Now, in the end, we want 4 more digits. So I'm going to put /d and 4 more digits. Great. I think we grabbed everything here. So I think this is everything we need. Okay, let's test this in our code. So I'm going to switch to freeCodeCamp. Okay, now right here I'm going to create a regular expression, and it's going to be, let me make it more readable. Inside this one. Okay. Now what we want to do is regular expression dot test, and we're going to test the string, and this will return true or false. Let's console log this one. Okay. Okay, so it works for this one. It returns true. Let's run the tests. There might be something still wrong. Okay, so it's not covering this case. Okay, so we should make it explicit here that we need to start with a number. So I'm going to use the caret here, and in the end I want to put the ending with a $sign. So this means that this is the pattern I want explicitly. So I don't want anything before this and nothing else after this. Okay, so now it should work for all the cases. Okay, guys, so that's it for this challenge. I suggest that you go look at the regular expression chapters, because this one got a little bit more complex and confusing. So just make sure to brush up on your regular expression skills. Okay, thanks again for watching. Don't forget to subscribe, like, share the video. I'll see you in the next one. Bye bye. Hey guys, welcome back. so this is the last video for JavaScript algorithms and data structures projects, and we're going to write a cache register. Okay, so for this one I have already written my code, and I'm going to go through it line by line with you. Okay, it's easier that way because it's a bit more complicated and there are more edge cases. Now, what we need to do is we need to design a cache register drawer function, check a cache register that accepts a purchase price as the first argument, and it will be price. The second argument is cache, and the cache in drawer CID as the third argument. CID is a 2D array listing available currency. Now, the check cache register function should always return an object with the status key and the change key. The three statuses are insufficient funds, closed, and open. And the change should have all the change but split into different currencies. Different denominations of currencies. And the currency units, here we have a penny is 1 cent, a nickel is 5 cents, a dime is 10 cents, and so on. Now, let's see what I have done here. I first started by creating an object currency unit where we can have as property the denomination like penny, nickel, dime, quarter, and as value its value. So for penny I have put 1 and not 0.01, and I did that because it's easier to work with whole numbers, with integers in JavaScript, because if you use floats you will encounter some math issues in JavaScript, but for me I found it easier to just multiply everything by 100, since we don't need, so in the end we can still convert it into cents. So that's all I have done here. I have taken 0.01 and multiplied it by 100. So I created this object currency unit, and I have all the currency units and its value. Okay, so it's easier to access. If I want to know the value for a penny, I just do currency unit bracket penny to use the bracket notation. Now, so that's all there is to it for this part. Now, let's see the function where everything happens. We have the function check cache register. First, I calculate the difference between the cash that I receive and the price of the product, so I know what change I need to return. And as I said, I multiply everything by 100, so we have only integers, so we can work only with integers. So here we calculate the change. I call this change sum. Now, right here, I have just copied the value of the change sum and called it change sum check. The reason I do this is because I need to store this change sum somewhere, and since I will modify this below to perform some calculations, I just need to save a copy. And still right here I initiate change, which will be a 2D array, so I initiate it as an empty array and the status as an empty string. Now, I initiate the value for CID sum, so I want to calculate and store in this variable the sum of all the money in the register. Okay, to do that I just have to go through all the just to get the sum of everything in there. Now, filtered CID, I am filtering the cache in drawer, the CID array, because when you get the CID, as you can see here in some examples, you can also receive, yep, okay, right here. Here is a perfect example. We receive the cache in drawer only, so we get also some currency denominations with 0, with a value of 0. So we have 0 nickels, 0 quarters, 0 fives. So I don't want to check them because they have no value. So since we have no nickels, why bother going through them? That's what I'm doing right here. I'm just getting an array of cache in drawer, but I am removing the denominations that have 0. Okay? And I am reversing them. The reason I reverse them is that because when you enter the CID, usually it is entered starting from the lowest denomination like penny, nickel, dime, but I want to start going through the largest one like 100. Okay, and the reason I do that is because now I want to calculate if I have enough money to give the change right here. And to do that, I'm just going through all the money I have in the cash register, starting from the 100 bills. Okay, so I am doing a for each to iterate through all the filtered CID. Now the element here will be an array which will store an array like this one, penny 1.01. It will store the currency denomination and the value we have at the cash register. So the currency, and so element is an array with only two elements. The first element is the currency and the second one is the value we have. Okay, so I'm getting the currency here, and the currency sum I'm initiating right here, and it will have the value for that currency at the cash register, and I multiply by 100 so I can work with whole numbers. Okay, now CID sum, which is being calculated, I just started it at 0, and since we're going through all the currencies in the cash register, I am just adding it to the CID sum, and when we finish this for each array, we will have the sum of money we have in the register. Okay. Now I have initiated this amount variable here, initiated at 0. Okay, and inside I have a while loop inside this for each, inside this for loop. What I am doing here, I am checking if change sum is still larger than or equal to currency unit currency. So currency unit is this object here. So when I am at the first iteration, I am checking if I have to return a change sum which is larger than or equal to, let's say, $100. And I am also checking if the currency sum, if I have cur sum, is measuring how much I have of that denomination in the register. Because if I don't have any left in the register, then we cannot give it as change, of course. So I need these two conditions to be true for the loop to go through. Now, the amount will be the amount of this currency denomination I am getting from the register for the change. So I am increasing every time the change sum is still larger than the value of the denomination. I am adding, for example, in the 100, if I have to return a $200 change, I am going to have to take two $100 bills. Okay, so it will go through two iterations in this while loop. And the change sum, every time we add the $100 bill to the amount we want to return, we decrease it from the change sum. So now we have only $100 to get to complete our change sum. So that's why we decrease the change sum by the value of the denomination we are adding. And the currency sum, of course, is also being decreased because we are taking from the register. Okay, and if the current sum goes to 0, then we don't have any more money from the denomination to take. I know it's a bit more confusing, but we have to cover all these cases. Now, after this while loop has finished, for one iteration of the for loop, inside the while loop we go through and take as many bills or as many coins from one denomination as we can. Now here we check if the amount is different from 0, we push it into the changes with the currency name and the amount divided by 100, since we want to give now the real value. So that means that when we go through some denominations in the cash in register, for example, maybe we don't need $100 because we need to change, we need to give a change of only $2. Then for the $100, we just go through it, the while loop we don't go through with the while loop, and we don't want to push it into the change, since we don't want to say I'm going to give $0 $100. We just want to get the denominations that we want to return. So I am pushing into the change array only the denominations that I'm going to return. Okay, so, and of course, if the amount is not 0, for example, if I have to return two $100 bills, I'm going to push into the change array, for example, the currency 100 and the amount 200. So we have $200 in $100 bills. Okay, after this for each loop and while loop, then we have the change. Now we go through the different cases. So if change sum is larger than 0, that means that we couldn't complete our change for whatever reasons. We don't have enough money in the cash register, or maybe we need to return 50 cents, but we have only a $100 bill, so we cannot return $100 bill. And then we just need to return the status insufficient funds. And the change is just going to be an empty array. And here we have an else if the change sum is to 0 and the change sum check is equal to CID sum, so that means that the change sum is 0. So that remember that the change sum is always decreasing here, and it will be 0 if we have already created the whole of the change from the money in the cash register. But if also the change sum check, which was the copy we created right here, the original change sum, is equal to the CAD sum, so that means that we have the exact same money we need for change in the cash register. It means that after we give this change, we don't have any more money left. The status will be closed, and the change will be equal to the CID, since we are returning everything we have in the cash register. We are giving it as change. And else, so else will be the cases where change sum is equal to 0, so we have paid the change, but we still have money in the register. The status will be open. Okay, so we need to return the status, an object with the status and the change. Okay guys, so I know it is a bit more confusing, but this project needed you to cover more cases. Now here is the one of the tests. Let's, as you can see, we give to the cash register the price is 19.5 and the cash is 20, so we need to return as change $0.5, and this is the amount of money we have in the cash register. Okay, so what is it doing in this case? In the cash register we have exactly $0.5 in pennies, so, and everything else is 0, so it will go into this one. So we're going to return closed, since we return the 50 cents we had in the cash register, and we're closed. We don't have any more to give as change in the cash register, and we need to return the CID as the change. Let's run the tests. Perfect. Now guys, this was the last one from the algorithm data structure challenges. It was a long one. Make sure to check out all of my videos if you want to see how I solved the exercises. And I'm also going to put everything into my GitHub. So the code for this exercise and for all the others is going to be on my GitHub page. I'm going to put the link in the description. Thanks again for watching. I will continue with the freeCodeCamp series and with many more videos. Thanks again. Don't forget to subscribe, hit that like button, share, and support the channel. I'll see you in the next one. Bye bye.